Good morning. My name is Andrea Crawford. I'm a distinguished engineer with IBM. And we're going to be talking today about deploying applications into the cloud multiverse, otherwise known as deploying clouds across deploying applications on multiple clouds. Sorry, coffee hasn't gotten to the bottom yet. Today we're going to have a little bit of a talk in addition with a stunning demo of our multi-cloud deployment capabilities with Jenkins. And so I'd like to introduce my right-hand man and senior technical staff member, Chris Lazzaro, and our senior DevOps engineer, Hollis, Chui. Go ahead, guys, take it away.
Thanks, Andrea. So we're going to talk about the challenges of deploying across multiple clouds environments. So we've got people moving to the cloud, but what they find out is that there's lots of different cloud providers. They have their own private cloud, and it starts to really quickly become not just a single cloud, a hybrid cloud, but actually we're getting more and more into the multi-cloud area. And the motivation for that is that cloud is accelerating digital transformation. It reduces that bottleneck that you have with infrastructure concerns because you can easily spin up, shut down services, and scale them as you need. But what we're finding is that only 20% of enterprise workloads have moved to the cloud. So why is that? And it's related to all of those challenges. When you first experience the cloud and you're spinning up your first Node.js app and it's already up and running, you're amazed at how quick you can get that MVP going. But as you scale that up, you start to realize that you need to connect it to your back-end systems, you need to use a service from another provider, and the complexities start to add up really quickly. Now, I'll tell you, I have a problem because I came to this conference and I saw all of the cool origin stories, and I wanted to just rewrite my deck. Because Tara's presentation and Koshi's really resonated with me, and my own story starting out as an intern with IBM doing build verification. And if you heard Tara's presentation about all the different platforms that she had to support, I had the same thing. We had 15 different platforms that we supported, and we had a massive Perl infrastructure like she did, deploying the builds, testing them. And as an intern, my job was to keep that stuff up and running and also to kind of work on the edge case scenarios. And so one of the edge case scenarios that we had, one of my first assignments was to see if our, what was called the NetWare gateway would work on a Japanese NetWare system. And I had never used NetWare before. I don't speak Japanese, but I got the two systems set up side by side, and when I would enter the command on the English one, I would just kind of follow the prompts and the gibberish and enter the same command when the Japanese one looked the same. So I was kind of living this problem that we see dealing with complexity and dealing with all the different operating systems, and also seeing kind of the common solution. We can script our way out of anything, but it starts to become more and more overhead as you're dealing with all these scripts. And at some point, tooling starts to help. But the real problem is that all of those multi-OSs start to have operating system lock-in. It's, you've got Windows, HPUX, AIX, Solaris, and then within those you have the different flavors. We had Sonos and 3 different types of Windows, NetWare. And they were all just a little bit different. And building the application binaries, they had to be built and tested very uniquely on each flavor of every operating system. So what are the things that back then people would do to deal with that challenge? Scripting helped. Java was a key helper, but Java really became write once, test everywhere, and the overhead there. Virtualization was really key. As we started to deal with VMs and we could run virtual machines that were then portable across different environments, if we could abstract and run on the VM, then things became more consistent. But as you all know, virtual machines are gigantic, and they're very difficult to manage, 5, much less hundreds. So they're not kind of the final solution on this. And as we move to containers, we see it's a lot lighter weight. But the real thing across all these multi-OS and vendor lock-in was moving to open technologies and the rise of Linux as an open platform to drive innovation. And that's what I think was one of the key things that helped to move the industry forward, is starting to standardize and adopt open source technologies as a way to get through and get past this vendor lock-in. So now let's look back at where we are today. And we've got all these different cloud providers, and they're all a little bit different. And you need to build an application that runs across all of them. It's the same problem. So we need to get to an abstraction layer where these different clouds become easier to manage. And we also need to use scripting where it makes sense, but also have that higher level tooling and capabilities that will reduce the overhead of the scripts. We don't want to get into this massive Perl environment that I was trying to support as an intern. So we're at an inflection point in the industry. Multi-cloud is becoming the new multi-OS, and we want to avoid all of the problems that we've made in the past. And IBM, as you're aware, is doubling down on open technology. We've been a strong supporter of open source for many years now. And we see that our partnership and now acquisition of Red Hat is one of the key ways to deal with this challenge. By adopting and standardizing on open technologies like Red Hat and Kubernetes, and then the higher enterprise level ones like OpenShift, we can start to address some of those problems across the multiple cloud environments and use the Kubernetes and container layer as our abstraction point as we build new software. So IBM's taking this approach, and even though the acquisition is just closed, we've already built this into our strategy. We were down the road of containerizing our software, and now we are making it official that OpenShift is our abstraction layer. We will run our middleware and our value-added applications using operational services on top of a standardized OpenShift Kubernetes provider. And from there, we can run on all those different clouds. So when we look at this, we're starting with 5 different cloud packs. So Cloud Pak for Application is going to help you as you're building, deploying, and running your applications. So it's got capability in there for running serverless, WebSphere, OpenLiberty, moving those into OpenShift. So it's got the OpenShift environment as well, and all of the developer tooling that can help you with that. So we've got Cabanero, Tecton, a lot of the services that you saw today are part of our Cloud Pak for Applications. Taking that same approach but focusing on data, we've got Cloud Pak for Data for collecting, organizing, and analyzing your data. And then as you're integrating with other systems and building your API strategy, we've got Cloud Pak for Integration. IBM has a strong set of business process tools as well, and that will come in with the Cloud Pak for Automation. And tying it all together, one of the focuses of this presentation is the Cloud Pak for Multicloud Management. So looking at that more closely. Here's the breakdown of some of the things that come in IBM Cloud Pak for Multicloud Manager. And this is what we're going to actually be demonstrating next. So we're going to go through some of these key capabilities and show you the actual application and how it can help you get above that scripting layer, but also integrate with Jenkins as well. So we'll be using Jenkins in our example. But some of the services here are simplified multi-cluster management. So teams aren't going to be using just one cluster. They're going to have multiple clusters in their environment. Policy-based role and compliance management. As you start to work across these different clusters and across these different clouds, security becomes a key issue. And how do you support security and compliance across these environments? The multi-cluster application management, so moving up into that higher level of managing applications. And then the integrated operational tools, so that you can standardize some of the operations and not have to be using different tools depending on where you are. And this whole thing will work across public and private environments. So taking a closer look at our demo environment, we've got the big picture here where on the far right, you've got different cloud providers, and the different cloud providers are all running different versions of a Kubernetes service or an OpenShift service, whether it's on Google or Microsoft or Amazon. And then in the middle, we've got our multi-cluster manager, our multi-cloud manager that also has OpenShift environment. That is connected to Git via our Jenkins pipelines, and we've got master and slave there. And we're going to be demoing today the items in the red box, but you'll see that this easily extends to whichever cloud provider you're actually using. And so now ask for any questions, but any questions so far on what we're showing here? Yes?
In the red box, the IBM Cloud Manager, right? So for that OpenShift, so does it mean that that is the sort of package which is talking to OpenShift or EKS or Azure, or are they coordinating directly? So are they like a set of libraries that they have already deployed somewhere, and they are sort of reaching out to every Kubernetes clusters deployed across clouds? Is how it is?
So the multi-cloud manager, the question is about the role of the multi-cloud manager versus the different cloud providers. And we're going to show some of that in detail, so we'll see that running. But the multi-cloud manager is kind of playing that coordination role. And in our demo, it will also be running the application on the OpenShift that's inside of it.
So Chris, maybe you want to explain about the clusterlet and how that is an agent that gets installed
Do you want to?
on the other Kubernetes clusters in this diagram here. Okay?
Yeah.
Yeah.
He's asking about the cluster.
Yeah, so this is probably a good transition point, and Hollis has another chart that goes into a little more detail on the environment. And any other questions before we get into the demo details? Okay, well, Hollis, let's see the demo and talk about the clusterlet as well.
Okay. All right, thank you, Chris. And so my name is Hollis Chui. And so to answer your question, so there's two pieces. If you want to install the Multi-Cloud Manager Hub or the Multi-Cloud Manager Clusterlet, they all come in Helm charts. So as long as you install the clusterlet on your target Kubernetes cluster, so agnostic of any platform, you then use the hub, and it will communicate out to each cluster across both private and public clouds.
And you install that clusterlet using IBM Cloud Manager?
Exactly. You install it on your hub, and then you have to install the Helm chart on each cluster. Cool. Okay, so for the demo, what we've got essentially is, so I've got a cloud-native application. There's a web front end and a couple of microservices deployed on both my two clusters there. So application source code, my Jenkins file, my Docker file, my multi-cloud manager YAMLs, they're all hosted in GitHub. I've got a Jenkins master-slave combination configured. So it's been configured to run all my jobs in a pod. I could have done this running inside a Kubernetes cluster, so it's containerized. You could have it on VM as well, so either option would work. And there's, as you can see in the red box, I've got 2 clusters for this demo. So the bottom one serves 3 purposes. So one, it's going to serve as my multi-cloud manager hub. Second, it's serving as my centralized container registry that all my deployments are pointing from. And third, it's going to serve as my development cluster. Okay? The second cluster on the top is going to serve as my staging cluster. So just to kind of re-expand upon, so Multi-Cloud Manager really provides a mechanism for like DevOps teams to manage security, compliance, software configuration, and application deployment in a consistent manner. Right? From this one central hub, or my cluster, I can deploy applications in a consistent way. So before I get to the demo, I just want to kind of show, so the demo is going to show how Jenkins can work with Multi-Cloud Manager to deploy applications across any Kubernetes cluster across like a mix of private or public clouds. Right, so how is this done? As I mentioned, there's really there's more than 5 resources, but the 5 I'll kind of reference here is all the multi-cloud management material is managed through YAMLs. So the first one you can see in the middle is an application. So the MCM application resource, these are all CRDs, right, custom resource definitions. It provides MCM with a single way to manage and monitor your workload. So I have this one application that bundles all my microservices, my web front end, everything together. I have my deployables YAML, which all it does is it references my Helm chart, right, whether it's in a GitHub repository or wherever it might reside, as well as the Kubernetes namespace I want to deploy it to. The placement policy YAML, this is where it will define where I want to deploy my Helm chart to. So it uses labels to define which cluster I want to deploy. So for example, if I had my development cluster with a label called environment equals to dev, I can specify these labels inside my YAML, and MCM will then process that and deploy the application to my target cluster. Okay? Placement bindings allows me to bind my deployable and the placement policies together. And finally, the one on the right, the application relationship. So this YAML basically defines a relationship between my deployables and my application, and it uses weave scope to gives you a visualization of your MCM application. Okay. So let's hop over to the demo. Okay. So as I kind of mentioned, you can see, I'll show you the app.
Exit PowerPoint.
Oh. Okay, so I've got an application called Blue Compute. Here's the web front end, and it's got a catalog of old IBM products that you could purchase, right? Like typewriters, et cetera. So this is my development cluster. So this is what's currently deployed there. And then here's a similar, here's the URL for my staging environment. So right now, both my dev and staging has the same version of my microservice Helm chart. My same web application is all the same. Okay? I've got my GitHub repo for the web application, right? And you can see, for simplicity's sake, I put in all the multi-cloud manager YAMLs in here. I've got my Jenkins file, the Docker file, my application source code. And I'll show you a little bit more some of these YAMLs in a bit. I've got my Jenkins pipeline that's going to do, so here's my, it's just like a typical CI/CD pipeline, right? It's going to check out the source, build an image, deploy to my dev cluster. I put in a little pause to, if I want to approve my deployment to stage, and then finally it's going to clean up my workspace. Okay? And here's a view of the multi-cloud manager. So I will talk a little bit more about some of what you can kind of see from this view, but I just want to show you from here that what I referenced about the MCM application, you can see here's my Blue Compute application. And within this, It's got all those deployables, the bindings, everything I talked about is all listed here. And you can see from the diagram, all right, hopefully you guys can see that okay. So this gives you a view of everything that's currently deployed. And you can see down here, these are Helm charts, right? It's tracking the Helm chart and which clusters I have it deployed to. So you can see, for example, right, the demo is going to be modifying my web application. So you can see here right now for my web application, I've got it deployed to dev, and then it's using Helm chart 0.3.22. Right? I've got the same Helm chart for the web application deployed to my staging environment using 0.3.22. So let's go ahead and look at my pull request. So here's my Blue Compute web repository. I already created a GitHub pull request, but I haven't approved it yet. So let's take a look. So what am I gonna do here? I'm gonna modify just the front text to write from Blue Compute Store to Jenkins World 2019. Right? And you can see inside here, for simplicity's sake, I've actually included my Helm chart, my package Helm chart tars. Okay, so let's go ahead and approve this pull request. And merge this to my master branch. And so what I've done with Jenkins right now is so I could have had a webhook that would trigger upon pull request approval. Because right now I have this on a private network, I'm actually pulling from the GitHub repository every 2 minutes. So the pipeline is going to run in a couple of minutes, but in the meantime, let me show you what the Jenkins job is actually doing. So if I look at my Jenkins file, right? So you can see my pipeline file, I've got 2 slaves. It could be working on slave 1 or slave 2. I've got my environment variable specified, so this is referencing my GitHub org, my credentials stored in Jenkins, my container registry URL, as well as the credentials I'm using. So first stage, I'm simply checking out, I see I'm doing a git clone. Second stage here, I'm actually pushing to my private image registry, right? So here's my credentials, I'm building the image, then pushing it into my private registry. The next stage is where I'm actually deploying this to my dev clusters. So right now I only have 1 dev cluster in this demo, but I could have a cluster across all cloud platforms, and it would actually, this piece here, this stage, would actually deploy to all my clusters with that specific label. And you can see here, right, some of the best practices, right, that you guys might know already. Like, I'm running this stage inside a pod, right, a kubectl pod. Right? And I'm not pulling from Docker Hub. I'm pulling from my centralized container registry, right? So I could have my image scanned. It passes all my security compliances, and I'm actually running it from there as opposed to Docker Hub. Once it's done, I've got a placeholder for my tests, right? And then it's going to prompt me to see if I want to deploy that same Helm chart into my staging environment. Okay? So let's go take a look at the pipeline. So you can see the pipeline's kind of gone through, right? And it's pushed the image. It's updated to my dev cluster. So if I actually go back to my dev URL, let's go to the front page and refresh. And you'll see it's Jenkins World 2019. So I know that the new image got replaced, and I can verify this from the Multicloud Manager. Right? So if I refresh this page, this diagram, you'll see that in my dev cluster, see, here's the Helm chart that's currently deployed to my dev environment, and it's now using Helm chart 0.3.23. Right? So if I go back to my Jenkins, so say the tests have executed and whatever your CI/CD process is, so let's just say I've got approval to promote it to my staging environment. So let's go ahead and proceed. Right. And even if I just look at the console output, so here's really the stage. It basically is updating my deployable YAML with my new Helm chart that I got pushed, and then I'm updating it and deploying it to my cluster. So now if I go, so the pipeline should be complete now. Right? And then if I go back to, this is my staging URL, right? So if I refresh this, right? So now my same change has been promoted to any cluster that I designated as my staging. Okay. So that's the kind of demo. So you can see with a simple pipeline, just a regular Jenkins job, I can actually deploy a change across any number of clusters. Right? So it really makes someone in a DevOps role, it makes their job a lot easier because you've got a centralized place. All your files are just YAMLs, so it's easy to configure, easy to update, and you can ensure a consistent deployment. So let's take a look at a little bit about the Multicloud Manager. Right? So before I get there, I'll just show you the YAMLs first, just so you guys have an idea. So the YAMLs it's pretty simplistic too. So if I take a look at the YAMLs, you can see here's my, So here's my deployable YAML, right? So this is kind of like the meat of it. You can see my deployable YAML is pretty straightforward. I've got the name of it, certain labels that I've designated, and then the key things is the deployer. So I'm saying I want Helm to do the deployment, and then here's my link to my Helm chart. Right? And then here's the namespace I want to deploy it to. Okay. If I want to take a look at, here's my placement policy, right? So what this is saying, so this is the other key piece, is that this placement policy, MCM will use this to figure out which cluster I want to deploy it to. And all it is using match labels. So under this section here, right, I can define a label, so environment equals to dev, that I want to deploy it to, or you can have some regex expression to figure out all the cluster, all the different labels. So it's pretty flexible. That's my placement policy. And then the application relationship really defines that visualization I showed you. So these YAMLs are all up on github.com, so you guys can always view this. So let me just hop back into this Multicloud Manager view, and I just want to go through some options. You can see if I was in a DevOps role managing multiple clusters, right, this view gives me a view of here's all my clusters. Are my clusters compliant? What's the state and health of my pods, as well as my cluster? You can easily see all that in one view. Right? And you can see here, for example, right, this clusters drills down into my specific clusters that I've designated dev and staging. Let me zoom in a little bit. So you can see here the labels. So this is the key piece, right? So those match labels that was in my placement policy, it's going to compare against these labels I've assigned to each environment. Right, so we talked about the application. So here's my Blue Compute application. And again, right, you should really source control all your MCM YAMLs in the GitHub repository. But as an operator, I could have the option of, here's all my deployments, and here's the placement policies. So for example, right now, let's just say that I've got a new microservice that the development team's been working on. It's called how to place orders in my catalog, right? You can see that currently it's only deployed into my cluster that's designated as dev, right? This pod doesn't exist in staging right now. If I wanted to deploy this into the staging environment, I could go ahead and just modify this to be using the label. So this is a label that exists for both clusters. I make this submit. Multicloud Manager will now take that request, update, and it'll actually go ahead and deploy it to my staging environment. Oops. So let's take a look. So now if I take a look at my Blue Compute, the orders microservice, before it was only deployed to the dev, and now you can see it's been deployed with both my dev and staging. And I can verify this if I seed my kubectl, go into get pods, and you'll see this new pod gets spun up. Okay. And it also gives you a view of If you want to check which Helm releases has been deployed, the state of your pods, storage, it has all of that management capability built in. Okay. So one last thing I did want to mention is, so we talked a little bit about security and compliance. So I've only showed you deploying applications through these YAMLs. There is also a MCM resource for compliance and policies, right? So it's the same concept as the application. I can define a policy YAML. For example, if I want to have specific network policies that's enforced on all my clusters, or if there's certain compliance like HIPAA, GDPR, I could code this in a policy YAML, define it inside a compliance MCM resource, and then as operator, I can, this is all managed in Git, and an operator, I can then enforce these policies across all my clusters and easily see, are my clusters compliant? So you could have your security team own your YAMLs, and as operator, I just need to make sure all my clusters are compliant. So it makes it really easy, at least from a DevOps point of view, to manage any Kubernetes cluster, really. All right, and that concludes the demo. Do you guys have any questions?
Hollis, can you explain how you would approach a scenario where you wanted to have, say, a production environment that spanned Amazon, Azure, Google, IBM Cloud, spread across four or
Yeah.
One or more cloud service providers? What would the approach be with this combination of MCM and Jenkins? Like, what would someone need to do in order to have a multi-cloud deployment like that? And can you explain it in what constructs you would have to, like labels and things
Yeah.
like that, like what you would have to do?
Okay. So that's the beauty of it, is that if I wanted to do this deployment, so let's say I've got a cluster across all existing cloud platforms. For me to actually deploy something to production there, it's actually only a couple of steps, right? I just need to install my clusterlet Helm chart that allows the Cloud Hub Manager to speak to these clusters. I got to install it on each of my cluster. And as I go through that installation, you can define the labels that you want assigned to your cluster. And one of the things you could do too is you can think about everything needs to be highly available, right? So say if I wanted to have 2 clusters in AWS, one is in US South, one is in US East. I can create these labels that be region specific, right? So I would go through this installation wizard, define my labels, so I could say environment equals to production. Put this same label across all these clusters as I go through the install, and then that's it. If I want to deploy my application to prod, I just need a deployable. I have my deployable for the application. I just need a new placement binding YAML that tells the MCM hub to say, deploy this on these clusters with this label. So once I've created that, you updated the MCM with that updated these YAMLs, and the deployment will be done. So so I don't need to make any changes to my application, right? So that's like it's pretty like straightforward, simplistic. And one of the things we are going to build, so this stuff will all be on GitHub in my, and we'll keep building on these assets. So it really makes it simple. And as an operator, right, for me to view, I only just need kubectl, helm, and there is an MCM CLI, but you can do the same concept with kubectl. So you only need really those 2 tools, right? Sorry?
Is there a trial version of MCM you can use?
A trial version?
Yeah. Or is it open source already?
I believe there is there might be a community. Well, we do things in like community editions, right? These are kind of kick the tires. And I believe we do have a community edition of this. So what Chris was talking about before about the cloud pack for multi-cloud management, that is going to GA next month. But we've had some
And so like the beauty of it too is that those clusters you set up, right? As part of, you can use Terraform, some sort of infrastructure as code. You can bake into your Terraform scripts, for example, like I want all my clusters to be pulling from a centralized repository and only that, and not from Docker Hub, et cetera, right? So you have these baked in best practices that really makes it easy. And as an operator, you don't need to worry about, oh, is this secure? Do I need to worry, right? So it really helps take your mind off a lot of these things because you can have these baked in best practices. So inside, so this is my dev cluster, okay? So this dev cluster has a baked in Docker registry, right? So you take a look at the blue compute web that I built just now. So if I take a look, you can see the 2023. See that image it got uploaded when I ran this demo. So it's inside here. So all those.
The registry, the private registry comes as part of the cloud pack itself, right? You don't have to use it, but it's there if you want to. And that's part of the common operational services that Chris was referring to in the chart when we had the OpenShift and the common services as part of the cloud pack, 7 capabilities. So as long as you're kube, as long as you're containers, you're all good.
Thank you.
Thank you.